welcome to the tutorials for the Holloway homework. The Holloway homework for Year 12 Methods is a review of Unit 1 and 2 functions. So it's Chapter 1 in the Year 12 Methods textbook, and we've condensed this down into a little worksheet that has a variety of examples that cover the critical areas that you're going to need in Methods 3 4. Starting off with basic polynomials, in your handout there's some definitions of what polynomials are, and we've covered that before in Year 11. And then we move on to the actual use of polynomials, long division of polynomials, and then moving on to your graph work, so linear, quadratics, cubics, and finishing off with your chordic graphs. So just a quick recap of polynomials and how we use them. If px is the polynomial p, we could use any letter of the alphabet. Then what we're substituting in here, we see everywhere in the equation, the polynomial. So if you're substituting in 1, everywhere you see x, you're replacing that with the value 1. So 2 lots of 1 cubed minus 1 squared plus 4 ones, etc., etc. Evaluate that, it becomes a numerical answer, we end up with 2. Similarly with negative 2, we're substituting that in. Keep it in the brackets, any directed numbers you're going to have to be careful with. Cubing it will still be negative, squaring it will be positive. Okay, so keep those in mind, keep your set out nice and neat, and you should end up with a value of negative 35. And probably the most straightforward example is substituting in another letter. So this was p of x, and if we now substitute a into that particular polynomial, we end up with 2a cubed rather than 2x cubed minus a squared plus 4a minus 3. So that is the basic use of the polynomial. Here's a more complex example where you haven't been given the coefficients. So there's two unknown coefficients, a and b. We have 2 bits of information. If you have to find 2 things, you'll have to have 2 bits of information. Now they may be as straightforward as algebraic statements that are given to you, or you might have to go hunting in the words in the question to actually find out what those missing bits of information are. But 2 unknowns, you're looking for 2 bits of information. Same work we did here, we're substituting in 1. This time we're told that that answer will be 5. And when we substitute in negative 2, we're told that that answer will be 5. Okay, so both the same answers, that may not be the case, but we need to work through the fact that we are substituting in for x, not for a and b, we're substituting in for x into those 3 positions, and we will get a plus b minus 1 plus 3 equals to 5. Now I've been able to do that reasonably quickly because with a value of 1, 1 cubed is just 1, 1 squared is just 1, minus 1 is simply just minus 1. So that's reasonably straightforward to put down straight away in one step. We can reduce that down to a plus b equals to 3, which will be equation 1. The second piece of information is not quite as straightforward. We've got a negative number to work with, so I've kept it in a bracket like I did over here. Minus 2 cubed, minus 2 squared, I've got those directed numbers to work with again. Again, a and b are not known, so they're going to be kept as coefficients out the front. We're going to reduce it down as far as we can at this particular stage. So taking our numbers over to the right hand side, wouldn't matter whether we left them on the right or the left. I get down to this stage here, and I see a common factor of 4, so I'm going to divide everything by 4 to get it into its simplest form with whole numbers. Minus 2a plus b equals 0, that's our second equation. 2 equations, 2 unknown, they need to be solved simultaneously. Back in Year 10, you first met simultaneous equations, solving by substitution, elimination, graphically, and then the CAS calculator came along as well. The simplest method for me for this particular one is to solve using elimination, so a subtraction of equation 2 from equation 1, and we've got a minus 2a gives me 3a, and we've got b minus b, well that's what's eliminating b, and we've got 3 minus 0 equals to 3 on the right hand side. So you can see there a reduces down to 1 and b equals 2. There are solutions for those coefficients that will give those 2 particular values. Alright, moving on to example 3, and we have, not everybody's favourite, we have a division of polynomials. And the example I've given you here is a linear factor being divided into a cubic. So we expect to get a quadratic as a result. Okay, so the powers are important. You make sure you keep track of those as you do your division. I've colour-coded it. I will give you a link to a Khan Academy video as well that will go through in more detail the process, but really we're trying to follow a 3-step process. We're dividing, we're multiplying back, and we're subtracting. And you repeat that every time you end up below the line. So to quickly talk you through this one here, how many times does x go into 3x cubed? Well, that's 3x squared. So once you've got that above the line, you then multiply back. So 3x squared times this factor will give you the red. 3x squared times that will give you 3x cubed minus 6x squared. That goes in a bracket, we subtract it, we rule off, and we start again. Okay, so minus 4x minus 6 will give me plus 2x squared. I'm below the line, so I'm starting the division process again. How many times is x? Going to 2x squared. Goes in there 2x times. Once I've got above the line, I multiply back. So 2x times x minus 2. 2x times x will give me 2x squared. 2x times minus 2 gives me minus 4x. Close it off in a bracket, subtract it, work below the line. A lot of teachers will tell you to bring this down. If you keep your working set out nice and neatly, you'll see the x's line up, so I don't really need to bring this down here, but you may often see this written as plus 5x when this is dropped down just to line up. Not overly necessary, but if it does help you with your set out, by all means. And we're now looking at 5x minus 4x. Hardest part of this is probably going to be getting the signs right, and that ends up being positive 9x. Below the line, start the division process again. How many times is x going to 9x? It goes in 9 times. Multiply back, 9 times that factor, 9 times x is 9x, 9 times minus 2 is minus 18. Close it off with brackets, subtract it. You can bring this down, plus 7, and we have 7 minus 18 gives us a remainder of 25. So it's not a nice factor, we've got a remainder left over. So looking at how we reconstruct this, if this was the question here, this cubic divided by that linear factor, we get this as a complete answer, and we also get this as the remainder part. So just like with numerical work, we have this part divided by that part as our remainder fraction. Okay, and that's going to be useful for our graph work later on. Important skill, in the next video tutorial I'll show you an alternative approach, but you do need to be able to divide by polynomials in order to get these particular factors. Okay, next up, example 4.